Section 5.4, the Fundamental Theorem of Calculus, page 1. So it turns out there's actually two parts to the Fundamental Theorem of Calculus. We've already discussed the first part in section 5.3, where we were using antiderivatives to evaluate a definite integral. Therefore, it was from A to B. So now we're going to learn the other part of the Fundamental Theorem of Calculus. And the interesting part is this deals with a derivative instead of an antiderivative of an integral. So we're still going to define an integral to look like the thing I just circled, but we're going to specifically define a different function g of x. And so our integral is going to be of some function f of t, where t is the input. So that's the variable that we would be integrating over from a to x. And it's important that f is continuous on the range, which the interval for us is still a to b, and we're assuming x is some point in between a and b. So we haven't covered the entire distance or interval that we're integrating over. So below, I have a graph of an f of t function. It's this red line, and we're asked to evaluate it at g. Remember the value of the integral where g is 0, g is 2, and g is 4. So three different problems, A, B, and C. So part A, when I'm finding g of 0, the input variable x has been changed to a 0, so I'm going to integrate to that new input variable, and I'm integrating from 0 to 0 for my f of t function. So I'm looking at going from this point, to that point. I'm not covering any distance, and so if we're looking at it as area under the curve, if I don't progress along the curve, I don't gain any area. Now, when I'm asked to find g of x being 2, I'm going to integrate from 0 to 2 for the function that I see. So I've got this graph, and I'm only coming here to where x is 2. So I can see I've got this triangle that I've shaded in blue from 0 to 2, so it's got a base of 2. We can see that the output has a height of 5, and using the formula for a triangle of 1/2 the base times the height, the area of the blue triangle is 5 units. We were also asked to find the g of 4 function. So we're integrating essentially from 0 to 4, or we're finding the area on this curve from 0 to 4. Since we already have the triangle, we just now need to find the area of the new rectangle, and we can add that to our existing triangle whose area was 5. If I go from 2 to 4, I've gone 2 units along the base. I can see I still have a height of 5, and thinking width times length, base times height, I've got a 10 unit rectangle. So adding these together, the total area for the f of t function from 0 to 4 under the curve to the x-axis is 15. So I've kind of just broken this down in this language. Also, you could then be asked, even though we don't know what this g of x function looks like, we have some ordered pairs. When x is 0, our function height is 0. When x is 2, 1, 2, our function height is 5. When x is 4, our function height is 15. So even though we don't actually know what g of x looks like, nor did we know what f of t looks like, we have enough information to plot that. Let's look at a new problem. I'm asked to actually find g of x in this case, and then to find the derivative of g of x. So again, part A and part B, where I'm given that g of x is the integral from 2 to x of t cubed dt. I said that horribly, right? So I've just rewritten this piece over here. Now, to find g, I want to use the definite integral rule. That's where I take the antiderivative using the Fundamental Theorem of Calculus, part 1. So I'm going to take the antiderivative of the function and evaluate it from B to A. So coming back up here, I'm taking t cubed, and the antiderivative formula says add 1 to the exponent. This new exponent amount becomes the denominator of your fraction out front, and I'm evaluating it from 2 to x. So I'm evaluating it, plugging x and 2 into this function, where when I plug x in, I can't really do anything. I just have 1/4 x to the 4th. But when I plug 2 in, I've got 1/4 2 to the 4th. So 2 to the 4th is 2 4 times. 2 of those 4 2s, sounds crazy. It's going to cancel the denominator, so I just have 4th. So I have just found g of x. But I'm also asked to take the derivative of g of x. So I'm going to take the derivative by leaving my coefficient out front, bringing the exponent out front and subtracting 1. The derivative of a constant is 0, and I've just found g prime of x. Now the important piece to recognize here, my g function was unknown, but I was integrating t cubed. Notice I have x cubed. This is going to be a key component of the next video.